Hi, my name is Johannes and I'm doing my PhD at EPFL, which is the Swiss Federal Institute of Technology, Lausanne. My thesis is supervised by Professor Martin Rohrmeier, who is the head of the Digital and Cognitive Musicology Lab, DCML. My research is funded by the Swiss National Science Fund through a project called Distant Listening, the Development of Harmony over 3 Centuries. Today I want to present you with the Python library ms3 and how it can be used for creating and evaluating a corpus of annotated scores. As a running example, I will be using the annotated Mozart piano sonatas, which my colleague Markus Neuwirth and I have submitted for publication. The corpus in its final shape consists of a digital edition of the 18 piano sonatas as they appear in the Neue Mozart-Ausgabe. Our annotators have analyzed the scores and written their harmony and phrase annotations directly into the MuseScore files, resulting in roughly 15,000 labels. In this example, the first movement of Sonata 8 in A minor, you see the DCML annotation standard in action. The standard offers a syntax for encoding harmonic features. To every annotated corpus, we join the information contained in the scores in the tabular format TSV, which, unlike CSV, uses tabs as separators. The extraction of these tables from the MuseScore files is the main reason why the ms3 library exists. It is essentially a parser for MuseScore 3 files. Staying with the beginning of the A minor sonata, we see on the right side how such a note table looks like. Every note is a row, and the columns encode its position, pitch, and duration. Similarly, the columns of the annotation table, corresponding to the first 3 chord labels, encode their harmonic features and, of course, their positions, which are not shown here. Now, everyone can use their favorite spreadsheet or programming language to evaluate the data. For example, by simply counting. Counting, for example, the pitches and ordering them on the line of fifth reveals a bell shape centered around G and D. The blue dots in the second plot show the counts of the 20 most frequent chord labels enumerated on the left. The shape in this log-log system shows that the type distribution is similar to the one most commonly found in music and natural language corpora. Of course, there are no limits to what you can do with this data, but one thing I really like to look at are modulation plans. This chart uses the key information from the labels of the previous allegro and reveals exactly what we would expect from a first sonata movement in minor. A modulation to the relative major key on the 3rd scale degree, a development section with more frequent key changes, followed by a recapitulation in the home key A minor. Additionally, we can show temporary tonicizations in red and add in green further presence of the tonicized keys. In addition to the harmony labels, my colleague Markus Neuwirth has analyzed the cadences in all movements. Since there are much fewer cadence labels than harmony labels, it was possible to create the TSV files manually rather than entering the labels in MuseScore. That way, he was able to make use of his annotated prints to simply write down measure number and onset of each cadence's ultima and one of 5 labels making up our vocabulary. Combining these cadence labels with our harmonic annotations, we created flowcharts granting us an intuitive access to the harmonic makeup of the different cadence types, which was one of the main goals of this project. For example, in this aggregation of all 519 perfect authentic cadences, we see that the vast majority of them prepare the final tonic with a cadential 6/4 chord, which proceeds either to a dominant triad or to a dominant 7th chord. Although there are only 59 imperfect authentic cadences in the corpus, we see that this pattern repeats, the cadential 6/4 once more playing a prominent role. The same goes for the 38 deceptive cadences, although we also see quite some progressions from the final dominant to the secondary dominant of the 6th scale degree, before actually ending on 6. Of course, we could also be looking at what precedes the final dominance, but it is now time to proceed to the demonstration of how we use ms3 in our corpus creation pipeline. The creation of a collection of scores often starts with scraping files from the web, converting them to your target format, and then assessing the quality unless you're typesetting everything yourself. In our case, We used existing additions where we could, resulting in a smorgasbord of humdrum files, music XML files converted from Finale, and MuseScore2 files. This is a situation where the command ms3 convert comes handy, which simply uses your local installation of MuseScore3 to convert all these files to your desired output format. Once we ended up with the converted files, we needed to assess their quality in order to select the least erroneous ones and in order to opt either for a correction or rather for a completely new engraving. Here, the command ms3 check can help, especially when we save the output to a log file. It detects errors in the measure numbering, repeat structure, and rhythmic irregularities. The same command, ms3 check, can be used for testing your annotations against a regular expression which matches only syntactically correct labels. Since our annotators upload their annotations to GitHub, we have included this command in a GitHub action or webhook. For every commit, the small check or cross indicates whether there are syntactic errors, and the annotator can go directly to the log to see them. This is practical insofar as our annotators are music theorists and experts in music analysis, but not necessarily in command line tools or Python. Another GitHub action comes very handy in the review of annotated MuseScore files, namely ms3 compare. The schema here shows 2 consecutive reviews of the same annotated MuseScore file. Each of the reviewers pushes their changes to a separate Git branch, and before merging it back into the master, the original annotator needs to review the pull request. This demo shows how I committed some changes to the A minor annotations we saw earlier, and upon launching the pull request, GitHub calls the command ms3 compare and automatically pushes a new MuseScore file containing a diff of the labels, which the annotator can then easily check and decide whether they agree with all the updates. And last but not least, I will use this Jupyter notebook to show how to insert annotations from TSV files into MuseScore files. On the right, you see the directory where the notebook sits. The folder ms3 contains the annotated Mozart sonatas, and the folder cadences, the manually created cadence labels. First, I instantiate a parse object and have it load both the MuseScore and TSV files. Then I parse them while specifying that the labels are contained in a column called Cadence. Then it is just a matter of matching the files and asking ms3 to add the cadence labels to the left-hand staff. The method store_mscx then lets me create new MuseScore files containing both harmony and cadence labels. I am looking forward to your feedback, questions, bug reports, and annotated corpora. Thank you very much.